Hi, folks. So I'm still in the Earth. Temperature's dropping a little bit. It's down to 86. I'm going to do some more math with us. So I was in Khan Academy on quiz 3, and I came across this question. And I thought I'd do it Sal style. So it says, which expressions are equivalent to x squared plus 64? And then it's got all these choices down here that look like they've been factored from x squared plus 64. So let's take a look at that. Now, x squared plus 64 is a lot like one that I know factors, which is x squared minus 64. I've seen that one factor before. That's something called difference of two squares, which can factor into x minus 8 and x plus 8. So you see we've got difference of two squares. Here's the difference, subtraction. X squared is a square, and 64 is a square. It's 8 squared. And that factors into x minus 8 and x plus 8. These two terms have a special name. They are called conjugates. They're not complex conjugates. They're just conjugates. So we have the difference of one of the signs between the two. If we multiply this back out, we can see that we get the first times the first is x squared, and then the first times the last gives us plus 8, and then the inners gives us minus 8x, and those lasts gives us plus, nope, here we go, gives us minus 64, or minus 8 squared. So we have x squared plus and minus the same amount here. Those two cancel to 0, so those go to 0. Then we have minus 64, leaving us with x squared minus 64, but we have x squared plus 64. So if I had something that when I multiplied it together could give me this as a positive number, that would be much better. What could do that? Well, we're in the middle of a complex numbers unit. So what if we were to find x squared plus 64, if when I multiplied these two together, I had something that would multiply that by -1, I would be a winner, chicken dinner. So that would be x minus 8i times x plus 8i. So having those two be I means that I would still get all the other terms the same, but I would get x squared plus 8xi minus 8xi, so those go to 0, minus 64i squared, predictably giving me that -1 value here, so I would get x squared plus 64 when I multiply it out. So x squared plus 64 does indeed factor into two binomials. They happen to be complex. And that also is this one right here. So I've got that solution. And if I slide back over to Khan Academy and click submit, it's going to say, check the rest of your answers. There are more solutions available because this is not the only correct answer. Something else in here is correct as well. The best way I see for answering the rest of these is to try them, to do them out and see what I get. So let's try A. So here's A is going to be x plus 4i. That's supposed to be a plus, started out being a 4, times x minus 16i, all. Let's fix this one out. Okay, second try, x plus 4i, not much better, x minus 16i, and we are subtracting 12xi. If I do this, I get x squared, this times this, x minus 16, so 16xi, and we have plus 4xi, and the last gives me minus 64i squared. All right, well, I got the x squared, I've got the minus 64i squared, and then I still have minus 12xi. So these pieces here combine to give me negative 12xi, and this minus 12xi does not cancel with that to 0. They don't subtract away because they're both negative. This right here is negative, and this right here is also negative. So that means this is not going to lose those terms. So there's no way that that one can be. So A is out. Wow, that felt really good to cross it out, but I kind of want to look at it. So I'm crossing out and looking at that, not A. Check this out. I've got plus 4i minus 16i minus 12xi. Looking down here, this one only differs in that the part that's being added is the 16i, and the part that's being subtracted is the 4. So that would, in this realm over here, give me plus 12xi. Let's try it out. So C would be x plus 16i times x minus 4i minus 12xi. So I'd get x squared minus 4xi plus 16xi, just like I hoped for. And then these two are negative 64 I squared. And all of that still has minus 12xi because we have done no operation that interacts with that part. So these two here give me plus 12xi when I do combining like terms. I still have x squared. I'll have minus 64i squared. Over here I have negative 12xi. And this piece and this piece subtract away to 0, leaving me x squared minus 64i squared, which is x squared plus 64, giving me this as a second solution. Now this one's interesting. It's not going to work though, because this division here is not going to work out to a large enough value. Now I'm running out of room here. So let's try B right here. B is going to be that x plus 8i divided by x minus 8i. And this division is the same as x plus 8i times 1 over x minus 8i, which is going to be the same as, I got that x plus 8i. I'm going to multiply it by its multiplicative inverse. That's what we did here. But I'm replacing the multiplicative inverse with what it's equal to without having an imaginary number in the denominator. So that gives me in the numerator x plus 8i. And in the denominator, I'm going to have the modulus squared, or the absolute value squared, which is the square of this coefficient, which is 1, plus the square of this coefficient, which is 16. So 1 plus 16 is going to be 17 down in the denominator. So I don't see any way that 17 is going to fall out. And I also have x plus 8i and x plus 8i here. And the winning combination of two things multiplied was when they were conjugates, not complex, conjugates over here. So we don't know what x is. So this has no path forward that's going to get us to what we want. So I'm going to go over and submit C and D as my correct answers. Let's see if I can make it to that and actually share that moment of getting the confetti with everybody. So let's go ahead and choose C and choose D. And how do we do? All right. Well, you didn't get to see me choosing them, but I got them right. Thanks, everybody. I hope that this helped you. If you got exactly that question on the quiz, I would encourage you to take the quiz another time to get a question that is different from that one. And I'm going to stop sharing now, and I hope that helped. If you have any issues at all while you're working on these, please do reach out. Thanks a lot. See you. Bye. Are you on a